Hello everyone, in this video we are going to realize the frequency response of common collector amplifier using Electric Circuit Studio app. First of all, frequency response means how the gain of the amplifier varies with wide range of frequencies in order to know for what range of frequency the transistor of the amplifier amplifies the signal efficiently. Then common collector amplifier output is observed across the emitter load which is in phase with the input signal. That is, there is no phase shift between the input and output signal. It has zero phase shift, and it is also called as a emitter follower circuit because output follows the input, and it is also called as a unity gain amplifier. In ideal condition, the CC amplifier has a unity gain, but in practical condition, CC amplifier has a gain less than 1, and it is also called as a buffer amplifier because if we give 1 volt as an input, the same 1 volt can be obtained at the output, so it is called as a buffer amplifier. And it is also used as an impedance matching circuit because it has high input impedance which reduces the loading effect, and it has low output impedance which makes it to deliver the maximum power to load. Then this is the circuit for implementing. Now we will implement the circuit. This is the element bar used for fetching the elements. This is the toolbar used for editing the elements. This icon used for varying the parameters of the elements. This is for seeing the flow of electrons in the circuit. This is for running the circuit, and this is for deleting the element. This is for rotating the elements. Like that, there are many tools. Finally, this is the action bar. Now we will implement the circuit. First, fetch all the elements and edit the value according to the design. We want two capacitors with 1 microfarad. Fetch the capacitor. Defaultly it has 1 microfarad, so don't change. Then rotate the element according to the structure of circuit. By selecting the element, click on the rotate icon. Then another capacitor. Then resistor with 150 kilo ohms. Click on the resistor and edit it by clicking on the edit icon. Change the value of resistor to 150 kilohertz. Then another resistor with 150 ohms. Change it to 150 ohms. Then another resistor with 10 kilohertz. Then another resistor with 4.7 kilohertz. Then power supply with 12 volt. Then function generator with 1 volt amplitude, and change the frequency to 10 hertz. Then finally one NPN transistor. Edit the model of the NPN transistor according to the circuit design. We have fetched all the elements. Align all the elements according to the circuit. Now we will connect all the elements using the wire. In the element bar, the first icon, which is like pencil, select the icon and connect one end of the element to the another element. Like this we want to connect the elements. Now we have connected the circuit. Finally attach the ground. Then another ground to the source. Now the circuit is ready for a simulation. Before running the circuit, we have to change the circuit property. In the action bar, click the three dots, go to circuit properties, choose the analysis type as DC. I have already done it. And in AC analysis, define the start and stop frequency. I have given 1 Hz as a start frequency and 1 GHz for stop frequency. It depends on your frequency response. And then type 2 decades, which is x-axis divisions. Then we have to observe the output voltage waveform. We will get the output voltage across the emitter load R3. So select the volt 1 of R3 resistor, edit it for a showing plot, graph and cursors for calculating the bandwidth. Then change the number type to magnitude. Now we will run the circuit. Click run and show all. Here we have obtained the output waveform. Now we are going to calculate the bandwidth. For calculating the bandwidth, we need to find the maximum voltage. By adjusting the cursor, we can find the maximum voltage. We have observed that 986 millivolt as a maximum voltage, that is 0.9 volt, which is approximately equal to 1 volt. As we have given 1 volt as a input, we are obtaining the same 1 volt as a output, which shows it is a unity gain amplifier. For calculating bandwidth, we need cutoff frequencies. So we need to multiply the maximum voltage with 0.707. Multiply maximum voltage 0.986 into 0.707, which gives 0.6971, approximately equal to 0.7 volt. So place cursors pointing 0.7 volt. I am using cursor 1 for pointing 0.7 volt in the upper frequencies. and pointing a 0.7 volt in the lower frequencies using cursor 2. You can see I am approximately pointed to 0.7 volt, and we can observe the difference of these two cutoff frequencies FH and FL here. 593 megahertz, which is our bandwidth of our amplifier. And that's all about this experiment. I hope that this video is useful. Thank you.